Good morning. Now in today's session we are going to discuss about the moment of inertia of a solid cylinder. For that, consider a solid cylinder of length L and mass m and radius of curvature r. Okay, so what will be the mass per unit length of the cylinder? M by L. Now first let us find moment of inertia about the axis. Okay, so before beginning, let us assume that this solid cylinder is made up of a number of thin circular discs. Let there be a number of thin circular discs placed over the other, and this will form the solid cylinder. Okay, that is this. We assume that the solid cylinder that we are going to consider is made up of a number of thin circular discs placed one over the other, as shown in the figure. One such circular disc is shown here. Okay, let that circular disc mass be m. Okay, so we are assuming that the solid cylinder that we are considering is made up of a number of thin circular discs placed one over the other. See, one such thin circular disc is shown here. Let its mass be small letter m. Then moment of inertia of the disc about the axis of cylinder will be mr square by 2. Okay, now so that is the moment of inertia of one such thin circular disc. Okay, now the solid cylinder is made up of a number of such thin circular discs. Okay, so how will you find the moment of inertia of the solid cylinder? You will have to sum this one, that is sigma of mr square by 2 will give you the moment of inertia of the cylinder. So r square by 2 sigma m. Sigma m is capital M. So mr square by 2 will be the moment of inertia of the solid cylinder about the axis. Okay, now let us find moment of inertia about an axis passing through the center of mass and perpendicular to the length. Consider the figure. Let z dash be the axis of rotation. Now to obtain moment of inertia about that axis of rotation z dash, what you do is you just consider a disk of thickness dy at a distance y from the axis of rotation. See, this is a solid cylinder and we assume that it is made up of a number of thin circular discs. One such thin circular disc is shown here. Its thickness is dy and it is at a distance y from the axis of rotation z dash. Okay. Now, moment of inertia of the disk about the diameter, that is moment of inertia of this one about the diameter, is given by actually moment of inertia of the disk is mr square by 4, right? So in this case, your mass, that is mass of this thin circular disk, is given by mass per unit length into thickness dy. Okay, then r square by 4 is the same. Okay, now you just apply perpendicular axis theorem to get moment of inertia about the axis of rotation z dash. So moment of inertia about z dash will be the sum of moment of inertia of the disk about any diameter plus one more term is there. What is this term? This is nothing but moment of inertia of a thin circular disk. That is there will be many circular discs like this. Okay, so similarly just consider one more and its moment of inertia will be similar to this. Mass, that's mass will be mass per unit length into its thickness dy and its distance, that is distance from the axis of rotation is y, so y square, that will be the moment of inertia. So moment of inertia about z dash will be the sum of moment of inertia about any diameter and the moment of inertia of the thin circular disc. Okay, now to get moment of inertia of the whole cylinder, what you have to do? You have to integrate this expression from minus L by 2 to plus L by 2. As usual, when you change the integral from minus L to plus L, you have to multiply with the 2. Then it will change like this. See, you are changing the limit of integration from minus L by 2 to plus L by 2 to 0 to L by 2. So you have to multiply with the 2. Okay, this we have already discussed in the earlier class. M by L is a constant, so you are taking it outside. And what remaining is written as such. Okay, 2m by L, r square by 4 is a constant. What is integral 0 to L by 2 dy, or what is integral dy? It is y. Okay, then what is integral y square dy? Y cube by 3. Then just apply the limit 0 to L by 2. On applying the limit, you will get the moment of inertia as m into r square by 4 plus L square by 12. That is the expression for moment of inertia of the solid cylinder about an axis passing through the center of mass and perpendicular to its length. Okay, next one, we are going to find moment of inertia of a solid sphere. Consider a solid sphere of mass m and radius r, and here let the density, what is density? Density is mass by volume, right? So density rho is mass by volume, means it is a solid sphere. So what is the volume of a sphere? 4 by 3 pi r cube. Okay, now first we will find moment of inertia about a diameter. For that, let y dash be the diameter. Okay, it is a our aim is to find moment of inertia about this diameter y dash. Okay, now for that, you suppose that the solid sphere is divided into a large number of discs. Okay, one such disc is shown here. Let its thickness be dy. Okay, and you name it as AB, and it is at a distance y from the center O. Okay, so from the figure, using hypotenuse theorem, what will be the radius of that disc? It will be root of, this is r and this is y. So radius of this disc will be root of r square minus y square. Okay, now volume will be this radius, volume will be this one, that is what is volume? Area into thickness. Thickness is dy, right? So pi dy. Here what is the radius? This one, you take the square, so it will be r square minus y square and pi dy. Okay, so area into thickness, that will be the volume. Now what will be the mass? You know volume, then how will you find mass? Density is mass by volume. You know volume, so how will you find mass? Volume into density. So this is your volume. Volume into rho, density, will give you the mass of that disc. Okay, now you just find moment of inertia of the disc about y dash. It is obtained as this one. As you know, moment of inertia of the disc about diameter, we have already derived it as mr square by 2, right? So here your mass is this one, so write it as such. And r square, what is your r? Root of r square minus y square. So r square will be r square minus y square, okay, by 2. Okay, then you just simplify this. R square minus y square is here, r square minus y square, so it will be r square minus y square the whole square. Now you just expand this term, so you will get this one. Okay, so let it be there. So this is the moment of inertia of the disc. So in order to obtain the moment of inertia of the whole body, what you have to do? You have to integrate it, right? That is in order to get the moment of this is nothing but moment of inertia of that single circular disc. Now the solid sphere is made up of a number of such circular discs. So in order to find moment of inertia of the solid sphere, you have to integrate it. Okay, from minus r to plus r. 1 by 2 is a constant, take it outside. Rest everything is kept as such. Okay. Now next one. Here you are changing the limit. Minus r, the integration limit from minus r to plus r, you are changing it from 0 to r, right? So what you have to do? You have to multiply with the 2. So see, half is kept as such. Pi rho is a constant taken outside. Since you are changing the limit of integration from minus r to plus r to 0 to r, you have to multiply with the 2. That 2 is written here. Rest everything is kept as such. Okay. Then next is simple integration. That is 2 and 2 get cancelled. So pi rho, what is integral r raised to 4 dy? It will be r raised to 4 is a constant. So integral dy is y. Then minus 2r square is kept as such. What is integral y square? Y cube by 3. Okay. Plus what is integral y raised to 4? Y raised to 5 by 5. Then apply the limit 0 to r. Okay. Now here also you just write pi. We have already written rho as m by 4 by 3 pi r cube, right? So just substitute that value. Then after that you just apply the value r, that is in place of y you are substituting r. So r raised to 4 y will become r. So it will be r raised to 5 minus 2 r square. In place of y cube you will write r cube. That is, you are just applying the limit that you know. Finally you will get the answer as 2 by 5 mr square. That is the moment of inertia of the solid sphere about a diameter. Now we are going to find moment of inertia of the solid sphere about a tangent. See, for that you have to consider the tangent, this one, which is drawn parallel to y dash, and let I1 represents the moment of inertia about the tangent. This one, let ICM be the moment of inertia about the diameter, and let I1 be the moment of inertia about the tangent. Okay, so as per Parallax's theorem, this you know, I1 is equal to ICM plus MA square. Okay, this is IT, that is tangent. Okay, so let IT be the moment of inertia about the tangent, this one, and let ICM be the moment of inertia about the diameter, that is y dash. So as per Parallax's theorem, IT is equal to ICM plus MA square. But moment of inertia about the diameter, that is ICM, we have just found what is its value, 2 by 5 mr square, right? Now here your distance of separation between the two, that is A is nothing but the distance of separation between this diameter and the tangent. It is equal to r, right? So A is equal to r. Now just substitute the values. I substitute the value for ICM as 2 by 5 mr square, and MA square will become mr square because A is equal to r. Okay, on substituting these values, you will get IT as 2 by 5 mr square plus mr square, which is nothing but 7 by 5 mr square. This is the moment of inertia of the solid sphere about a tangent. So these two are important. There is nothing much confusing. You just understand the concept, then it will be very easy. First understand the figure, then write it down in a paper, each step. Okay, then do the integration. If you know integration very well, then it will be very easy. Okay. So both this one, solid cylinder and solid sphere, both are very important. Thank you.